Hello YouTube, this is Mr. Bakari, and today we are going to solve triangles with the law of sines, specifically triangles where we're given angle, angle, side, and angle, side, angle. Okay, so what do we use this for? Well, whenever we're solving, and that's finding missing angles and sides to non-right triangles. So that would be an obtuse triangle or an acute triangle. So here we've got an obtuse triangle ABC, and the way this is put together is sine A over its opposite side, A, is equal to the sine of B over its opposite side, B, which is also equal to sine of C over its opposite side, C. Okay, and that is the law of sines. Now, this does not work for every scenario. So what does it work for? Well, it works for an ASA, which is an angle side angle triangle. That is where we're given one side between two angles, as you can see right here on the left. It also works with an angle angle side. That is when we're given one side that is not between the two angles, as you can see right here in the middle. And it works with side side angle. That is when we're given one angle that is not between the two sides. Now, this one has an asterisk next to it because this is a special case that we're going to look at in another video. So look for that video where we just talk about solving using the law of sines with side side angle. In this video, we are just going to focus on angle side angle and angle angle side. All right, so let's look at a couple examples here. It says solve triangle ABC if angle A equals 42, angle B equals 57, and C equals 67. So what I like to do is the first angle I come across, I like to put it in the bottom left-hand corner. That's just what I like to do. So I'm going to call that angle A. I'm going to put B up top. So I'm going to label that B, which would make this C. Now you could label it the other way around. You could go counterclockwise. It doesn't really matter. Just be careful. Make sure B is in between A and C. Now we're given side C, which is 67. So now once we label it, we check that we labeled it correctly, we have to look at, we're given one side between two angles. That is known as angle side angle, and that is one we can use the law of sines for. So that's what we're going to do. So before we get started here with the math, we're going to take note for what is it we are solving for. So I do not know angle C, so I've got to find that. I do not know side B, so I'm going to look for that as well. And I don't know side A, so I'm going to solve for that. All right, now we can find this angle C by just taking the sum of a triangle's angles is 180. So if we take 180 and we subtract 57 and 42, that's going to leave us with our third angle right here. So that would be 81 degrees. So that wasn't so bad. We've got our third angle here. I'm going to just put that in here. All right, now we need to use the law of sines to find our missing sides here. So that's what we're going to do now. All right, so I'm going to take sine of A, which is sine 42 degrees, divided by the opposite side, which is my unknown. So I'm just going to put a lowercase a, and that is equal to, now I can take the sine of 81 over 67, or I can take the sine of 57 over b. But I've already got an unknown here. So when I set this proportion up, I've got to have two quantities here. So I need to use sine of c, which is sine of 81 degrees, divided by its opposite side, 67. Okay? So now that I've got one unknown, I'm good. Now, before I can put this into the calculator and solve for side A, I've got to isolate A. So I'm going to go ahead and do that. So A is equal to 67 times sine of 42 degrees divided by sine of 81 degrees. All right, now that looks good. We're going to get our calculator. I use a TI Inspire, but you can use anything with trig functions on it. And we're going to put this in. So I'm going to say up top 67 times sine of 42 degrees divided by sine of 81 degrees. And for this video, we will round to the nearest hundredth place, and I get 45.39 for A. All right. Okay, so now we have to find B. So I'm going to start off the same way. Actually, I'm going to use sine 81. And the reason why I'm going to use 81 is because I rounded side A. So I don't, if all possible, I want to put in values that I'm not rounding, because every time we round and then we do more math, we deviate from the right answer. Okay, so I'm going to use sine 81 over 67 equals, and then we'll go sine of B, which is 57 degrees, divided by side B, and there's our unknown. Okay, so again, we're going to isolate our unknown, and we get 67 times sine of 57 degrees divided by sine of 81 degrees. Okay, so now we're going to go ahead and put that in our calculator. So I've got 67 times sine 57 degrees divided by sine of 81 degrees. And to the nearest hundredth place, that is 56.89. And we are done. We have solved for the missing parts of our triangle. Okay? Let's look at one more. This one says solve triangle DEF if angle E is 38, angle F is 72, and E is 12. So again, take that first angle, put it down here in the bottom left. We'll call that E. I'll go ahead and put F up here, 72 degrees, which leaves us with angle D down here in the right-hand corner. And this time we're given E, which is across from angle E, of course, as 12. Now, we're given one side that is not between the two angles. So two angles in the side, that is angle, angle, side. And we can use law of sines to solve this. Okay? So let's take a look at what we're solving for. We do not know angle D. We do not know side F. And we do not know side D. All right, so those are our three unknowns. And again, we can find this last angle by subtracting these two from 180. So we will go ahead and do that. And we should get 70 degrees. Yep, 70 degrees, that's right. Okay, so we got angle D. All right. So now we're going to have to use the law of sines to find side F and to find side D. So let's get started here. I'm going to go sine of 38 degrees. So I'm going to use sine E, 38 degrees, divided by its opposite side, 12, equal to, now I'm going to look for F first. So I'm going to set that equal to sine of F, which is sine of 72 degrees, divided by F. So F is my unknown. I'm going to isolate that variable, and I get 12 times sine of 72 degrees, divided by sine of 38 degrees. All right, put that in my TI. 12 times sine of 72 degrees divided by sine of 38 degrees. And to the nearest hundredth, we are looking at 18.54. 18.54, and that is F. All right. Now to find D. So I'm going to start off the same way. I'm going to use sine 38 degrees. Now in this second step, again, if you can do this without taking a rounded number that you already rounded, that is always the best route. So that's what you want to do. So I'm going to go sine 38 over 12 equals sine of D, which is sine of 70 degrees, divided by D, our unknown. Once again, we will isolate our unknown. So that's going to be 12 times sine of 70 degrees divided by sine of 38 degrees. All right, one more time. 12 times sine of 70 degrees divided by sine of 38 degrees. And we get 18.32 for D. And we are finished. So there we go. All right. So hopefully this gives you a good idea of how to approach this. In the next video, we're going to look at the special case, which is your side-side angle. And in doing that, we're also going to look for angles. So join me in that next video, and I'll see you there.